Hello, math students. This is Mr. Zacek again, and today we're looking at systems 3 linear, quadratic, and circles. And you know, to way of review, what are we looking for with systems? Well, the first thing is on the graph, we're going to look for the point of intersection. Okay. And when we're looking at linear, we're thinking about things that are in slope-intercept form, or y to the first power and x to the first power. Quadratic, y equals ax squared plus bx plus c. Again, we don't have to have all of those parts, but we need to have y to the first and x squared. And then circle, x minus h quantity squared plus y minus k quantity squared equals r squared. So in that case, we're looking at x squared, we're looking at y squared, and we're looking at r squared. Okay, so we're going to do some more examples here today. Hopefully we're getting more comfortable and confident with this. And number one that we look at is kind of has a couple special cases for us to be aware of. The first is we've got x squared plus y squared equals 16. Now here I want to recognize that this is a circle, and I have y equals 4, and I want to recognize that this is a line, only to the first power. So when we graph circles, the first thing we're looking for is the center. Hey, what are we doing with x and y here? Well, there's nothing attached, so that's when the center is at the origin, 0, 0, and then r squared is 16. The square root of 16 is 4. So some common mistakes, people will divide by 2 to get the radius, or, just leave it as 16. So real quick sketch of the graph. So we're centered at the origin. We're going to go north 4, 1, 2, 3, 4, to the right 4. We're going to go south 4, and we're going to go west 1, 2, 3, 4. All right, and again, so there's our equation, and we're looking at x squared plus y squared equals 16. Now, our line is y equals 4, and so here's where we have the special cases. And we talked about these the other day, but just to review, when you have x equal a number, that represents a vertical line. And when you have y equal a number, that represents the horizontal line. Now, the one little trick that sometimes can screw people up is x equals 0. Now, what did we just say? X equals a number is a vertical line. So x equals 0. That's also called the y-axis. And then when we have y equals 0, that's a horizontal line. We call that the x-axis. So that can be the part where people can get a little bit tricked up. But we've got y equals 4, so it's a horizontal line at the point where y is 4. Well, where are the y values for? Well, it's 4 here, and it's 4 here, and it's 4 here, and it's 4 here, and it's 4 here. Every point along this line, the y value is 4. So there's our line, y equals 4. And here we have an example where we only have one point of intersection. All right, it's only at 4 because that circle's radius is 4. So there's only, one point of intersection. So we could have 0 points, you could have 1 point, you could have 2 points. All right, so it was just looking for the total number. All right, now number 2, the graphs of the equations are drawn. At which point do the graphs intersect? Or I might say, what is the solution? So we have y equals x squared plus 4x minus 1. We have y plus 3 equals x. So I'm just going to get a different color just to mix it up here a little bit. Well, this first one, that's a parabola. How do I know that? Y to the first power x squared. My value of a is 1. My value of b is 4, and my value of c is negative 1. I like to find the middle first. So I use the axis of symmetry formula, which is x equals negative b over 2a Negative b over 2a, negative b over 2a, x equals negative b over 2a. So negative 4 over 2 times 1, that's going to come out to be x equals negative 2. So we make our table of values. We've got to have negative 2, negative 3, negative 4, negative 5, negative 1, 0, 1. Now, we learned the other day we may need more. But that'll at least get us started. So if we're going to enter these in, again, if you've got a graphing calculator, you're going to y equals x squared plus 4x minus 1. And you're going to go to your table, kind of arrow around till you get these. We've got 4 here, negative 1, negative 4, negative 5, negative 4, negative 1, 4. Okay, so and if we need more, we can easily get more. All right, so we're going to go left 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4, left 4, down 1, left 3, down 1, 2, 3, 4, negative 3, negative 4, left 2, down 5. Okay, and then we start to repeat that. Okay, so again, I've got some. Just going to lightly sketch this in. Okay, and let's look at the line. All right, well, as I look at the line, first of all, I see it's not in slope-intercept form, which is y equals mx plus b. So we can subtract that 3, use a little bit of algebra here. Now remember, the x and the 3, they don't like each other, so you can't combine those. Just write the form. So we got 1 over 1 for our slope, and our y-axis intercept is negative 3. And I get a little reminder, graph this first on here's our x, here's our y. Say we're going to go down 3, okay, negative 3. And our slope is 1, so we're going to go up 1 and to the right 1. Now you're going to see that way that those graphs, as we move in that direction, are moving apart. But I'm also going to go down 1 and left 1. Down 1 and left 1. Look at that. It's twice right there. So I just carry that out a few more times. Use my straight edge. Graph that line. Again, this line is a little thick, so that's part of the weakness of the tool that I'm using. So this is y plus 3 equals x, and this is y equals x squared plus 4x minus 1. And I've got 2 points of intersection. So one of them here is negative 1, negative 4. And the other point of intersection is negative 2, negative 5. And both of those are our solutions. Again, if you wanted to do a little algebra or just a quick little check, not really algebra, if you plugged those both in, it would have to make the left side equal the right side. So we have 2 points of intersection, and I thought it might have been one where we only had 1, but we had 2 there. So parabola and a line. All right, what is the total number of points of intersection in the graphs of the equation? All right, so here we are again, and we've got x squared plus y squared equals 16. There's 1. Y equals negative 2x squared plus 4x minus 1. So the first one we should recognize as a circle. When we have a circle, we want to do a little center radius. Here the center is 0, 0. R squared is 16. Take the square root, and therefore r is going to be 4. Over here it's a parabola. Value of a is negative 2, b is 4, and c is negative 1. We're going to do our little axis of symmetry. X equals negative b over 2a. So we got negative 4 over 2 times negative 2. Hey, that comes out to be negative 4 over negative 4, which is x equals 1. So in our table of values, 1 is going to be our middle. So we'll go 0, negative 1, negative 2, and 2, 3. Okay. So then we get y, and again here, no excuses. You can just substitute these in. If you don't have your graphing calculator, it's not that complex to do that. But if you do have it, makes your life a little easier. At -2, we're at -17. At -1, we're at -7. At 0, we're at -1. 1, 1, whoa, 1, 1, 2, excuse me, -1, and -7 here. So luckily this one's just asking for the total number of points. That'll make our life easier. Let's go back to the circle. Center 0, 0, radius 4, 1, 2, 3, 4. I go up 4, I go down 4, 1, 2, 3, 4. I go to the right 4, 1, 2, 3, 4. I go to the left 4, 1, 2, 3, 4. Use a compass. Circle tool here for us today. Oh, a little off. Okay. There we go. Now let's plot the parabola. -2, -17, I'm not going to do that one. -1, -7, 1, 2, 3, 4, 5, 6, down 7. 0, -1. 1, 1. 2, -1. 3, -7. All right, and from there, I'm going to easily be, whoops. I'm going to easily be able to tell that we have 2 points of intersection. Okay. So at this point, we should be cruising along here pretty well, and I think that we've done enough of these where this last one I think you know how to do. So I'm going to skip that one for today, and you can go ahead and do that if you'd like for a little extra practice. But hopefully you're getting it by now, and then we're going to do a little quick review, and then we'll be done with our systems unit. All right, have a good day. Bye.